Welcome, everyone. Kevin Carpenter here, and today I get to chat with Lisa Lippincott, who I love her talks. Now, I was talking with her earlier before we started this, and I have to say I am not a math major by any means, but I always find all of her talks very consumable and useful, and I come out of them better. And so for that, I'll let Lisa talk a bit about herself, and we can go from there.
So, hi, I'm Lisa Lippincott. I program for a living. I work at a company called Tanium, I've been doing this a while. But my background is in math. I originally was going to be a mathematician. That was hard to get a job in, and particularly mathematical logic. I really fell in love with the subject. And that really ties into programming because we would like to be able to show that our programs work correctly. And showing that things are so is, that's the bread and butter of mathematical logic.
And so that's, I get what you're saying, because that's the part where I was saying earlier, I watched one of your videos, and the way you break things down, that there's math involved. Like me, I consider myself more of a programmer than a computer scientist. And so when I write a function, it's like, if I'm passing in a byte as a parameter, I know that there's 256, variations that could be and what the result's going to be. But part of the reason I think about it that way is literally because some of the talks I've seen you give. So, but I heard in one of your talks, you said that you liked C++ because there are just so many large scale systems. And so that doing that kind of analysis on the programs that we do in C++ is even more enjoyable. Is that right?
I don't know if I can really say more enjoyable, more challenging.
Okay.
And one of the things, I've read people have been trying to do this for years. I first got interested in it when I read a book. It's back on the shelf someplace, I think, The Science of Programming, which I think came out around 1980. I read probably not very long after 1980. People have been trying to use more formal methods in showing programs correct for years, many years. One of the places I think these efforts founder is when if you decide that you are going to use a nice language that is limited in some way. It keeps you from looking at the hard problems. Mm-hmm. And so I early on decided, no, I want to be grounded in a real language that people use at scale so I can see what the real problems are. And so, C++ for me, it's like New York. If I can make it there, I can make it anywhere.
C++ is that way, isn't it? I mean, that is for sure. If you can program in C++, most other things, well, maybe except for assembly, most other things seem to come kind of easier.
I mean, there are, other procedural languages you're pretty well set for. It doesn't, and I'm really focused on what goes on in procedural languages because, at this point, functional languages, everybody said they're going to be great for reasoning. And in some ways they really are. They are much more like the 100 years of mathematics that comes before functional languages. But I think the jury is kind of in. Most programmers are not going to be functional programmers. It's just, it's not happening. So maybe we can make the reasoning, make the mathematics work better with procedural programming.
Gotcha. Mm-hmm. So out of curiosity, I worked with another person once, back in 2000, that she had studied mathematics and moved to C++ too, and we were working on a project during the dot-coms. How long have you been writing C++?
Um, so that would be sometime in the mid 80s.
Wow. That's
it was still C front.
Yeah, that's where I was going to say.
Yeah,
it was
that was
C
the-
working on the plus plus.
Yeah. I remember, I mean, if somebody wants to look it up, when the first Macintosh C++ shipped as part of MPW, I think it was part of MPW, and it was using C-front, I'm like, I'm there. Because I was
Wow.
already doing, I was just starting out in C++ then, but everybody was just starting out in C++ then. So
That's kind of funny. So for me, I was in high school when we learned Turbo Pascal, and that was on the CPM machine. And then it wasn't too far after that I'd had my first PC with the Turbo Pascal, Turbo C 2.0 compiler. Obviously not writing professionally, but it's like that was my first exposure to it. And it's amazing to see how far we've come. And it just makes me think of when we hear talks and people are talking about, the Gang of Four books for patterns, or even like the books you're talking about, we've grown a lot, right? I mean, standard library, new standards and everything like that. But it amazes me, I guess, in a way, how much is still so relatable to those original discoveries that are from, a while ago too. So go ahead.
Yeah, I was just thinking, even back then, I'd actually started programming professionally by then as a student. It was, a way to make a little money. And, I'd been working in C, and, my reaction to C++ was like realizing that I had been hand coding my own virtual tables.
Yeah.
Like, oh, you can get a compiler that does that for you.
The virtual tables and stuff, I mean, it's probably not the same thing, but it makes me think about the first time I had to learn COM interfaces with Microsoft and all the pointers. Oh, yeah. Yeah, that takes me back days that I don't want to go back to. So this year you're giving a keynote, CPP on C, and your first time there, yes? Or your first time giving a keynote, or both?
My first time at CPP on C.
Oh, excellent. But you have been to London before.
Lovely. Yes. In fact, I was there, 5 years ago, I think. I spoke at ACCU.
Okay. So that is one conference that I have not got to go to yet. I'm racking up the amount of conferences that I'm hitting, but there's still a few that are on the list that I haven't hit yet. No, I have to say, I love the venue there, because it's just, it's a beautiful venue. It's like Aspen, but not quite so expensive. So the talk you're giving is Why Loops End.
Why Loops End.
So, I cheated and looked through part of the slides. I have not seen the talk before, but you want to tell us a little bit about it?
Okay, so it's a classic reasoning about programming thing. In fact, I feel a little like I'm sort of dodging a bit here, because really, I am, in some ways, I should be much more interested in the problems that are causing us big bug security issues, making the CVE list, and loops, making sure your loops end really hardly ever makes one of those big bugs. It's not a problem that is totally pressing, but it is a classic problem of why people think formally reasoning about programming is hard. Everybody knows about the halting problem, even if they don't really understand that. Well, okay, here's a talk of mine you can look up. Lightning talk I gave at Meeting C++ some years back. was the halting problem is not our problem. And so if you want to know my opinions on the halting problem, you can go see that. But anyway, it does turn out that making sure that your loops end is really important for formal reasoning, because if you can basically cheat out of your proofs by going into an infinite loop.
Okay.
So it's an important piece of the puzzle, even if it's not the one that's really causing us bugs.
Gotcha.
And so, yeah, I'm going to talk about the reasons why loops end and how you can express the reason why your loop should end in your program in a formal way.
That's cool. And for people that are coming to the conference, I have to say, like, one of the best parts with coming to the conference is Lisa is so available after, before, and during any of the conference. So, you know, when you have questions and you want to talk more, I mean, that's when I think of all the conferences I've seen you at, that's the best part is you're just always
it does
there.
Seem like the least I could do.
Yeah, interacting with everyone.
Yeah.
So I'm looking forward to seeing your talk. It'll be June 29th, I think, is when you have your keynote, but the conference runs from June 28th to June 30th. And if anybody's interested in classes, those run on the 27th. It's in Folkestone. It'll be beautiful because it's right there on the sea. I'm coming from Arizona, where right now it's over 100 degrees. So I'm looking forward to getting on the airplane. I appreciate you coming and chatting with me today, Lisa. And I look forward to seeing you there.
Okay, see you then.
Talk to you soon. Thank you.